Let's take a look at review problem 4.3, finding a best fit for an intrinsically linear regression model, y equals a plus bx squared. We call this an intrinsically a linear regression model because a very simple transformation will make this linear. If I let x prime be equal to x squared, then the equation simply becomes y is equal to a plus bx prime. And that is something that is linear and therefore can be fit using the techniques of linear regression that we already know. So here's the data that we have. Here are the xy's plotted in Excel. And so if I just simply draw the scatter plot for these things, we clearly see that we have a very nonlinear trend. And down here at the bottom, if I make this a little bit larger, is the last point for -38. So clearly this is not a linear trend. It looks like a parabolic trend. So we're going to delete this. So in keeping with the transformation that we have here, x prime equals x squared, let me add in a new column, x prime, which will simply be the values of x squared. So this will be a1, or a2 squared, pardon me. So 1 squared for 1. The next one will be 4 to -2 squared, and so on. So then if I draw this new scatter plot, I have this data, and then when I add the trend line this time, linear, let's put the equation on the chart and show the value of r squared also. Get rid of this. Here I have the linear fit to this line. So we see that we have y equals -2.5709x plus 6.9724. So those are the numbers that I will use in my model fit up here. So let me write those down so that the a is equal to the intercept here, 6.9724. And the b was equal to -2.5709. Okay, so that's the linear fit for the model. Make sure I got the numbers right. Okay, it looks good. And so therefore the fit would be simply y is equal to 6.9724 minus 2.5709 times x squared. Let's now talk about how to do this with the calculator. So over here is our calculator. And ahead of time I inputted the x and y coordinates. So here they're the x coordinates and there are the y coordinates. So the transformation that I need is to let x prime equal x squared. So I will let L3 be equal to the first list, L1 quantity squared. Okay, so here I have the new x coordinates and the y coordinates. So I will perform stat linear regression. The new x coordinates were in list L3. The new y coordinates were in list L2. And so we get the same numbers as before, that ax plus b, the a is equal to the slope, so that is going to be the slope -2.5709, and the b is equal to the intercept here, which is 6.9724. And so that will be the same result as we had using Excel, and so there is our best fit for this using this model.